Today we're going to be talking about derivatives and rates of change. There are two kinds of rates of change. There's instantaneous, which tells us how fast a relationship between two variables, often x and y, are changing at any given point. And then the average rate of change is the change in y over the change in x. Okay, so today we're going to be going over a few problems in how to do this. Okay, so our first problem here. It says, the rate of production of a pair of shoes is represented by a production formula of f of t equals 1200t minus 50t squared, where f of t is the number of pairs of shoes produced in a given time, and t is the time in hours since the factory shift started. Okay, so part A is asking us, at what time does the rate of shoe production equal 600 pairs of shoes per hour? Okay, so to do this, we want to know when is the exact time where the company is, or the factory, when the factory is producing 600 pairs of shoes per hour. Okay, so to do that, we take the original equation, which is f of t equals 1200t minus 50t squared. Okay, so we take this equation and we take the derivative of that function. So f prime of t equals 1200 minus 100t. Okay, so this is our derivative equation here. And we want to know when is the rate of shoe production equal to 600 pairs of shoes per hour. Okay, so to do that, we set this equation here equal to 600. So 600 equals 1200 minus 100t. Okay, so we have this here. So now all we have to do is simplify. So we move the 1200 over, and we get negative 600 equals negative 100t. And then divide each side by negative 100, and we get t equals 6. So we have our answer. So at 6 hours, the rate of shoe production is equal to 600 pairs of shoes per hour. And that is our answer for part A. So with this, we get at 6 hours here, the rate of shoe production will equal 600 pairs of shoes per hour. Okay, so that's part A. Now for part B, it says, at what time does the rate of shoe production stop? Okay, so this question is asking us, at what time does the rate of the shoe production equal 0? Okay, so to do that, we take the derivative, which was f prime of t equals 1200 minus 100t. Okay, so we have that. So now we set that equal to 0 because we want to know when the rate of shoe production stops. Okay, so basically now from here, you just simplify. So you take over the 1200, so you get negative 1200 equals negative 100t, and then divide it by negative 100, and you get t equals 12. Okay, so with this here, we have at 12 hours, the rate of shoe production is 0 pairs of shoes per hour. So given that, we have just solved this problem, and that gives us the rate of change using the derivative. Okay, so here is another example of derivatives and rates of change. Okay, so in this problem, it says if Audi spends X million dollars on advertising their cars in a month, they expect their profit to be the function P of X equals 80 plus 50 over X minus 35 over X squared million dollars. Okay, so the first question here, part A, is asking us, how are the sales changing when the Audi spends $6 million on advertising? Okay, so to do that, we use the function P of X equals 80 plus 50 over X minus 35 over X squared. Okay, so using this function here, we take the derivative of that function, and we get P prime of X equals negative 50 over X squared minus 70 over X cubed. Okay, so this is our derivative function here. Okay, so now, so when we plug in 6 into P prime of X, so then P prime of X, we substitute 6 for X, so we get P prime of 6. Okay, so to do that, we plug it into our derivative function here. Okay, so we get P prime of X equals negative 50 over 6 squared plus 70 over 6 cubed. Okay, so with that, all we have to do now is simplify all the way out. Okay, so that equals negative 50 over 36 plus 70 over 216. Okay, so with that, all we have to do is simplify that. So I did a little bit ahead, and I kind of just plugged this into my calculator. So that this equation is about negative 1.065. Okay, so our answer here is negative 1.065. Okay, so our answer here is negative 1.065. Okay, so negative 1.065 is the instantaneous rate of change where Audi spends $6 million on advertising. So we can conclude that when $6 million are spent on advertising, the instantaneous rate of change is negative 1.065 million dollars. Okay, so now we have part B. And part B says, how will the sales change between the first month and the 10th month, given that in the first month they spent $2 million and in the 10th month they spent $10 million? Okay, so this here is an average rate of change problem. Thus, to take the average rate of change, we take how much money they spent in each month and plug them into the original equation all over the amount of money they spent between the 2 months, or the difference, and we take the difference of how much money they spent in each month. Okay, so that looks like this. Okay, so P prime of C equals P of 10 minus P of 2 all over 10 minus 2. Okay, so this here is your average rate of change. Okay, so now we plug in 10 into our original equation, which is 80 plus 50 over X minus 35 over X squared. Okay, so we do that, we get 80 plus 50 over 10 minus 35 over 10 squared minus 80 plus 50 over 2, 50 over 2 minus 35 over 2 squared, all over 8. But we need to simplify it even more. Okay, so this here will equal negative 1.45. Okay, so negative 1.45 is our average rate of change. Okay, so negative $1.45 million is the average rate of change that their profit will decrease between the first and 10th month of advertising. Okay, so in the end, we got answers for part A and B. Our answer for part A was decreasing at a rate of $1.065 million, and our answer for part B was negative $1.5 million. $1.5 million is the rate at which it was decreasing between these 2 months. So that was the average rate of change. And this answer here, was the instantaneous rate of change. So given that, I hope you guys learned something from this lesson and that you come back and listen to more lessons of mine. Have a good day.